All right, so our team name is the Eye of the Dragon, and we were working on crowd dynamics. So our intent was to explore how we could use different Earth observation information, and as well as geomatics and geospatial data to support crowd dynamics and crowd simulation. So our group was composed of Kane, Lichin, Gong, JS, myself, Peter, and Sari. And as I mentioned, we were looking into crowd dynamics, so looking at the crowd behavior in mass gatherings. All right. So our initial thoughts was that we could use the Earth observation data to help us identify the obstacles to the crowd movement and use the social big data to help us with the population count. And so that was the initial assumption. Our event, we chose the event around La Machine, which occurred in July, between July 27th and July 30th in Ottawa. The event attracted quite a few people during those 4 days, so we're talking about an estimate of 750,000 people. And the runs combined of the two machines, so Longma and Kumo, they traveled for over 27 kilometers over a broad range of destinations in Ottawa. So our initial assumptions were that people are likely to follow the machines as they move through the city. And we also thought that people would be sharing that information on social media, so taking geotag pictures and so on, and that we could use the existing data sets to estimate the crowd density and then provide an input or a seed for the crowd simulation. So the data sets we explored, we looked at different Earth observation imagery, and I don't know if I can talk about that later on, but we ended up using the aerial image from the city of Ottawa, which was a 20 centimeter resolution, so that was the best resolution data set that we had, and it was covering the area of interest the area that was of interest to us. And we also used some of the data available from the Open Data Portal, namely, the hydro, all the context data, the framework information, and the sidewalks that are shown in green here that came from the Ottawa Open Data Portal. For the flow metrics, we looked at different things. So we looked at the spectrum data that was available from CRC, the counter data that was provided by University of New Brunswick. We also looked at the traffic camera data, the live traffic feeds available from the city of Ottawa, and the open signal data, also provided by CRC. And for social media, we looked at Twitter and Instagram. That's a nice picture. So, all right, lessons learned. The EO and geospatial data sets, that works. We can see the obstacles. We can see the obstacles that will create bottlenecks for the crowd movements and so on. So that works. Spectrum data, there's definitely something that we could do with it, but we'll see later that it was not covering our area of interest. So that's too bad. The counter data was not concurrent with the event, so that's just too bad. Traffic cameras, they provide an idea of what we could get, but these are live feeds, right? Open signal data, interesting data set, but in terms of mobility, for the time range we're looking at, the process is done maybe twice a day or over multiple days. So we're seeing movement but over a very long period. And what we're trying to look into is movement over a rather short period. So that didn't work out very well. Twitter was a surprise and didn't work at all. And maybe Instagram could provide a replacement for that. So what happened with the Twitter dataset, right? We were hoping to get issues associated with the crowd dynamics. So if people are seeing the machines very well, they're happy, and they're sharing that on Twitter, they're taking pictures and so on. If they're unhappy, because they can't see, because they're stuck or whatever, then they also share that information on Twitter. So we were hoping to get that sentiment analysis from this information. So to do that, we first extracted the geotag tweets from the downtown area between July 27th and July 31st. And then, based on the most commonly used tags during the event, using the #IfIMe tool, we extracted all the tweets associated with La Machine. Results, however, showed that, well, there were no geotag tweets associated with the event. So 13 tweets in total for our area of interest, but none of which were associated with La Machine. So that's too bad. And overall, there were less than 250 tweets associated with the event, all pretty much with the positive sentiment. So our recommendation, well, I guess we need to aggregate various social media platforms to really get a representative sample, or to get what we're looking for around a given event. It seems like Twitter is not, being used that much anymore. Then spectrum data. So our assumption here was that given that we have hundreds of thousands of people gathering in the downtown area, we'll get a peak in the spectrum usage. And our intent was that using that peak, we could somehow find a kind of regression to evaluate the amount of people that actually are in the downtown area. So what we did, we initially calculated the spectrum usage for the 26th to use that information as a baseline. Then we calculated the spectrum usage for between the 27th and the 31st. And well, there wasn't that much of a difference. That was surprising. So then we looked at the two previous weekends to get like weekends baselines and compared that to the spectrum usage for that was the 30 and 30th. Well, no peak either. So there was no peak compared to the baseline. So what we end up understanding is that, well, the spectrum reception station was too far away from the event location. So we're not getting the spectrum information from where the people are actually gathered. So our recommendation on this point would be to ensure that the receptor is within range, basically. So these are the results, just to show you that this is what we got for the weekend. There was a difference with the 26th, but you see that the other days, I mean, it's not significant that much. So looking at the other two weekends, well, we're seeing that there's not much of a peak. And this is the location of the spectrum antenna, the receiving station. So our assumption is that since the cellular phones have a high frequencies, they have a short range. There is a shorter range of pickup, and our event was in this location, so within a 5-kilometer buffer. So we didn't get the information we were looking for. So open signal data set, well, not concurrent, and measure were pretty far apart. So we see movement, but over the course of several hours or days. Counter data, non-concurrent, traffic cameras. So I talked about that already. So what we were intending to do, like I said, use the spectrum data to find out how many people are there, right? Then use the traffic cameras to delimit the crowd extent. So we have an amount of people in a given area, that's crowd density there. Based on this, assuming fixed density, then we use the geospatial information. So the sidewalk, we know that people will gather on the sidewalk, and we can find out how many of the people that are initially at the initial gathering will be able to flow through and follow the machine displacement. And discussing with Monica, we found out that this could also be helpful to validate results from crowd simulation models, which are very complex, and there is very little validation data available for these. So perhaps such a method that is very simple could be helpful in that sense, and also helpful as a kind of ballpark for event planners to determine if they have sufficient capacity for a given event. So looking ahead, we'd like to propose potentially interesting data sets. So the UAV, like infrared information or thermal information, could help in identifying actual people and determining crowd density. So that would be one way to go. Network of the beacon trackers would help us also get a people count, or at least a count on the number of devices that are within a certain area. We also discussed about face recognition software on security footage to help us with the people count. Also, these RFID tags, I don't know if you're familiar with these. For those of you who do marathon and such, you know, you have these tags on, and whenever you go through a scanner, it gets the time you go through the scanner, it is showed, it registered. So using different scanners, we could monitor the flow of people going through with these tags. And we also finally discussed the use of autonomous vehicles as mean to acquire information on a given crowd. So yeah, as a conclusion, didn't work out quite as expected, but still was a valuable effort, I think. Very interesting and enjoyable as well. So good work, team.